Hello, everybody. I should say goedemiddag, bonjour, guten Tag. My name is Clemens. I work at Microsoft in Redmond. I work on the Windows Azure AppFabric team. I am from Mönchengladbach, just across the border originally. And I actually went there for a game on Saturday, and everybody who's following the Bundesliga in some way knows that we're not looking all that good right now. And that's all because of a Belgian goalkeeper. It's not my fault, it's your fault. All right, so this session is about Windows Azure AppFabric, about things that we have shipped, and about things that we're going to ship within the next 12 months. We'll have some announcements during the year. I'm going to foreshadow some of them. I can't give you all the secrets, so I have to keep some things from you, which you will be able to discover throughout the year. Also, welcome to all the people who are watching this on Channel 9. So, Windows Azure AppFabric, I'm going to give you a tour through all those capabilities, all the things that we have, and also give you a rationale for why we're building this, and why it's called Windows Azure AppFabric, and how that's related to the thing you call Windows, you know as Windows Server AppFabric, and what the future story on this is. So think of this as a roadmap talk, but I'm also going to show you the goods that we have. So I'm going to show you a few demos on the capabilities to get an impression of the things that we have in the portfolio. So it's about cloud, it's about multi-tenancy, about high density, it's about things that belong in the middle tier and some of the challenges. Also, really about the cloud and the special challenges that you have when you build cloud-based software. So we start with when you look at demos for server applications these days, very often you have it's all easy, 3 lines of code or no code, and you open up Visual Studio, wave your hands, and you have a ready-to-deploy production application. Probably not. But people still say, web is very easy. Here's a web. It's all the architecture you need to know in the world. Right? There's a browser, there's a web server, there's a database, and that's all we need. And then there's a little bit of infrastructure. Right? The database may be a classic database, so it's SQL Server or MySQL, or you listen to people who say, no, that's the devil, or it's something for old people. We use NoSQL now, okay? And then there's the web server in the middle, and people say, use ASP.NET, and there's the other camp over there that says, no, .NET, that's so yesterday, we do Ruby now. And then there's the browser with HTML5 and all those wonderful things. So web architecture really is very easy. And you have more browsers or more users. You just add more web servers because it's all stateless, except when it's not. So you have a little bit of session state, and that's the only thing you need to worry about, and your application is done, and it's all simple. Goodbye, have a good day. Well, not quite. People are building apps now, things that run on devices. You may have heard of that. Intensely personal little apps that keep a lot of state but don't have a lot of processing power, and those apps tend to go away because what we have learned in the mobile space, at least Apple has taught us that, and Windows Phone 7 is teaching us that, is that keeping all applications active at all times is not a good thing. So a bunch of multitasking work and background work is pushed down into the cloud. So you need services that are processing state on behalf of the mobile apps. Mobile apps have become very small, and it's actually a good thing to have very few features and be very focused and be very personal. So you're pushing a lot of stuff down into the client. Now what those apps have is also have a lot of scale. So all of a sudden, those apps now need to talk to services. Those services may also be built on the web technology, like MVC or Ruby or PHP. But since those applications also tend to accrue more state over time, and have to manage state, and also probably need to be a little richer in their interactions. We have services specifically that we're building. If you follow Glenn Block in his talk on the WCF Web API, where we have special API for RESTful services that's somewhat richer and is specifically for headless servers. So all of a sudden, you're adding that to your infrastructure, and you're making high-fidelity REST services, or you're making still high-fidelity SOAP services. And of course, you need to go and scale those and manage sessions and manage state even. So if you have a longer-running process that runs, and that process runs for a week, you need to go and keep that state around somewhere, right? And so you need to go and manage that. Then to those service layers, you need to have some authorization and some authentication. That's fairly easy. You just slap in a session or user provider for ASP.NET. But really, it's not that easy if you want to be contemporary and if you want to use one of the identity providers that's out there, Google, Facebook, Windows Live ID, any of those. So that's additional work that you need to do, go and integrate with those. Then those apps are not always online. I turned off so I have one of those too. My phone currently is only online when I'm on Wi-Fi, because it would cost me an arm and a leg to have that on 3G here. So my application is not always online. But what I would like to do is to be able to interact with my applications even though they're offline. So I would like to be able to tweet here, and then as soon as the phone sees network again, I wanted to upload the tweets. Unfortunately, none of those applications does that yet. But it would be nice if I had a queue, some intermediary that would be sitting there that I could go and talk to, that sits on the device, and that can then seamlessly go and replicate out to a cloud-based queue. It would also be nice if I could, in the same way, send messages back, and we have notifications infrastructure for that. And then you have a web server, and the web server gets a lot of pressure, and you have services that sit in the middle, and you want to go and decouple that. You want to have load decoupling between the web tier and between the services tier. For that, you need infrastructure as well. And then you want to get that data back. And then you have line on business systems that you need to talk to. Let's say you build a service, and that service, you can order something, and the order needs to be fulfilled then, so you need to notify someone to go and take that thing out of a warehouse and ship that to someone. So you need to tell a line of business system about this. That line of business system may not be sitting in the cloud, so you got to go and talk to that one and get something back. Then if your system grows, you may want to go and may need to go and partition your databases. You probably want to go and aggregate data up from multiple sources and hold that somewhere in a cache where you can easily get to it. So all of a sudden, that simple web architecture is not so simple anymore. So no matter what they tell us, the web architecture, web apps are not really simple, because they're really simple when you start, and then you have all this additional infrastructure. So that's not quite as easy as it initially seems. There's lots of things that we need to put on top of that. And I'm not telling you any news. At the cloud. So cloud is interesting, not only from a technical perspective, where it's somewhat similar to the things you know, but also from a business perspective. And this is where the multi-tenancy aspect actually comes in. So let's talk about ISV, because for ISVs it's really interesting, and also enterprises from a cost perspective. So here's the box model. Box we mean you buy a Windows server, or the customer buys Windows server and then puts software that you give them on top of it and runs it. So from a customer perspective, the business software business looks like this. They first have to build and buy a lot of infrastructure. Server switches, disk racks, server software, and all those things. And then they go and buy an ISV license from you. And over time, because that's something that as an ISV you want to have, is a steady income stream, you charge them maintenance fees. So from an ISV perspective, the goal here is to go and have more customers. And as you have the R&D costs spread over more and more customers, as the more shared components you have, the more you can spread it, the broader your margin gets. That's the ISV economics play that you have in software. There's an interesting story when it comes to the cloud. SaaS, specifically, is interesting because it's changing some of those parameters. The first thing is, there's no more infrastructure investment. The customer comes to you, and you already have the infrastructure for them. The second thing happens is that software is now being offered for rent rather than upfront licensing straight away, which actually makes sense because for most ISVs, the steady income stream, the money they depend on are the maintenance fees. So the software license goes away, which means that all in all, the customer upfront cost goes away, but that lowers the barrier of entry. So that's a really good thing for everybody. Think about Office 365. You just walk up, put your credit card down, and you can get an Exchange server. Or you get a Link server. And you just get that rented on a monthly basis, but we give that to you. So everybody who's doing SaaS, software as a service, is getting rid of all these pieces. Now, what does that mean in terms of, on the business side, for the customer? Well, the customer is charged some kind of service operation fee. The service operation fee may be flat, or it may be based on actual resources used. That's all depending on how you do those things. If you are a SaaS user, SaaS provider, you will likely you bind it to users, you bind it to something that the business customer can make sense of. And now the interesting thing happens. The graph is very similar. You have service operation costs that are somehow proportional to the fees that you charge. And your goal must be to drive those down so they get the same graph, so you get the same margin widening. So your R&D cost, that's still something you go and spread over your customer. So the previous picture stays true, but here now you get an additional angle here, is if you can run your services for as many customers as you can on as little resources as you can, your margin widens up. So that's an interesting thing to think about on the cloud, right? You can actually now monetize computer science because you can monetize optimization of systems. Higher density, more and more and more clients on the same hardware. Higher density means wider margins. This is why multi-tenancy matters so much. So we're running, at Microsoft, Windows Azure, SQL Azure, and the AppFabric are all multi-tenant systems where we can run thousands and thousands and thousands of customers shared on a pool of machines. We're still insulating them on the machines, but we don't give a VM to a customer, at least not in AppFabric, or not in SQL. Right? In compute it's a little bit different, but if you think about all the non-compute services, it's all co-located. So we try to pack as much as we can, and that's something that's also really attractive and very interesting. But it's changing the software, it's changing the way how applications are built. Because typically today, applications are not multi-tenant, but they're built for on-site deployments for a single customer, and then don't have the density that makes this curve work. So the keys to lower operations costs, the key to turn SaaS into a really profitable thing is deployment automation, self-healing architectures, auto-scale, high-density, multi-tenancy. So as an example, for instance, when I say self-healing architecture, people say, wait, what does that mean? That's science fiction. Not necessarily. Well, we have a back-end system. That's the provisioning system for Windows Azure AppFabric. So when you come to the Microsoft online commerce portal and put down your credit card and you subscribe to Windows Azure, what that causes is a record to be sent to us, and we start provisioning your account. We set up your DNS, and so we make a subscription for you in our system. When you further walk up to the portal, and we're going to do that later, and provisioning a new account, then we actually go and set up DNS, and we go and provision roles for you and do all those things. So there's a whole back-end enterprise app that sits behind there. And that enterprise app is just dealing with the fact that everything can go down at any point in time and nothing is really needs to be reliable. So that application can go and be failing in any state at any moment. And the application is built so that it can recover itself within a time range of 15 minutes from a bad state into a good state, or it notifies someone. So there's never a discovery thing that's happened. The application knows when it's bad, and it will heal itself whenever it can. So I have something on my blog that I referenced in the beginning that's pointing to this, which is about a resilient architecture that's self-heal. But the important thing is, our ops people never have to touch the app until the app is completely, unless the app is completely dead, in which case they will know through monitoring, or the app knows that its state is bad and then will tell the operator. But that's all knowledge that we accumulated and that we're now putting into the platform. And that is what Windows Azure AppFabric is about. It's about taking knowledge about high-density hosting and all the integration pieces and putting that into the platform as a piece of platform as a service infrastructure that's for you to use. So when we think about all these multi-application, multi-tenant, multi-user things, that's even complicating the picture that I had before. So that's a lot of work that you need to do to build multi-tenant apps. And so the goal that we have is over the course of the next 12 to 18 months to help you make that less of a pain and make that easier. So we have a set of services that we want to help with. So all that's not so easy. There's middleware that helps with that. So there's great choice of middleware that you have today for all of those pieces, and you'll be using some of it. So there's web service infrastructures that you can use. There's caching infrastructures you can use. There's workflow systems or stateful component systems you can use, access control models you can use, routing transformation integration services you can use. There's a choice of multiple choices that you can have. There's multiple cache systems. There's multiple access control systems. I mean, these are all components you can get from all kinds of different vendors. One thing you also need to worry about is obviously deployment. How do we get that onto the operating system? You have an app. How do you get that app installed? You have a choice between having an IaaS infrastructure as a service that sits somewhere that you can go and deploy to, or you can have an abstraction that deals with that for you, where it's about, do you have control and do you need control over how many machines your application runs on, or do you want to have that done for you? And of course, every single pieces of those infrastructures need to be configured and scaled. Every single one needs to be managed. And every single one of them has some programming model and tools that you need to deal with. So all this middleware exists. So what we try to do is we try to make this unified. We try to have a consistent programming model and a consistent tooling and a tooling infrastructure for all these kinds of services. We try to have a common management experience, and that's a really important one, so that you can go and create a new tenant, create a new namespace, and you can basically go and choose all the capabilities you need, and you can effectively script that environment. You can go and have us just stand up an environment to deploy your application into very easily by just saying, I need to have this much cache, I need to have a service bus namespace, I need to have access control, I need to have it all set up, but it's all consistent. You can manage it, which means you can also monitor it. You can see what's going on in a consistent fashion. And we're going to see that towards the end of the talk. And it's all built for box, appliance, and cloud, or ABC, that's what we call this, appliance, box, and cloud. What that means is there will be a cloud version. That's what we're doing right now, building the cloud version. There will be, of all the things I'm talking about, a server version. That's what the box is. And then there will be form factors where we bundle hardware and software and give that to you. So there's work that we're doing. We've announced this publicly, where we have a number of hardware partners and who we're currently working with to build cloud appliances. Those cloud appliances are for the largest customers that we have, and they take the shape of a 40-foot container. That's probably a little much for most. But we have other instances where you have, for instance, the SQL Server BI appliance, which is a blade you can put into a rack that is pre-configured with SQL Server and optimized for BI, and that's the kind of the direction where that goes into. So we will have appliances that run that kind of infrastructure that you can operate yourself. But where we basically take care of the management of the operating system, the integration that we install those things, you basically just go and get the entire appliance and just throw it into the rack. That's a little further out. So the one thing we're focusing on right now is cloud. The reason why we focus on cloud right now is that it's an old wisdom of distributed systems, that if you build something for local, you can't make it go and do remotely. You can't operate it remotely. You can't turn a local system into a distributed system. What we're finding is you can't go and turn a simple distributed system into a cloud scale system. So we're building cloud scale first, and then we're scaling things down. So AppFabric is the middle tier, and of course it's surrounded by infrastructure. So there's the composition model based on .NET and the tooling. There is the AppFabric management experience. We're going to see that later. And then there's a thing we currently call internally container. We don't have really a name for it yet. We're going to have the first showing of this at TechEd in the US in 3 weeks. And so we might find a name for it until then, but I doubt it. So that's the current working name for it. And that's the thing that actually hosts components. So you'll be able to go and give us components and host them. And I'm going to show you that also towards the end of the talk. So let's go and drill in and see what's really behind all these boxes. So the first question is, how do you go and scale your application? There's a number of questions here. I'm not going to read them all. But really, how do you get better scale out of your apps? And specifically on Windows Azure, there's a certain number of scenarios where it's beneficial, where you need high speed, where you need to have a cache, where you actually need to have a multi-tier cache that can help you making your applications better. So the cache service, the Windows Azure AppFabric cache service, will help you with that. The commercial availability is end of April 2011, which is kind of now. However, I'm not allowed to tell you when. However, count the days until the end of the month. Pick one. It's kind of tomorrow or Friday. So the cache service is going to be available commercially, and they're going to be announcing the pricing too. So that's all going to happen tomorrow. And that's coming out. The cache service is already available in the labs environment, appfabriclabs.com. We're going to take a look at that in a moment. And what is it for? It's a distributed in-memory caching for applications running inside of Windows Azure. The reason why we can say we constrain this to Windows Azure is because the cache only makes sense once you have appropriate latencies. So if you have an application that runs on-premise and you would be using the Windows Azure AppFabric cache, it kind of misses the point. Because then you have so much latency introduced into the system that it doesn't matter whether you hit the disk on the table store or they hit the disk on SQL, rather than having the backing cache. So there's a notion of co-location here with your compute instances for Windows Azure, and that's what this is built for. So the notion is you put an application into the data center in Amsterdam or in Dublin, so that's the Western and Northern Europe data centers, and you deploy your application there, and then you also enable the cache up there, and so you have those things co-located, and that reduces the latency so much that you actually get gain out of having that cache. The great thing is that this cache system is built on the thing you already know. So there's Windows Server AppFabric that has the cache inside, and the programming model here is completely symmetric. So this is the first piece of the AppFabric family that actually has a symmetric experience between on-premise and in the cloud, and the differences are mostly in configuration. There are some things that the on-premise cache can do that the cloud cache can't yet do. A few differences. Too technical to go into the details right now. But you get a consistent experience between the two. So the basic notion is you have a web role, you have a local cache that you can enable. So whenever you put something into the cache, the data goes into the shared cache, but then you can also retain things locally in memory. There's a little policy that says how long those objects can be retained in memory, and you mostly do this for data that doesn't change. So you can treat it as a database a little bit if you want to keep state around. But you can also go and just have read-only data that you need to cache, and it pulls the data up into the local cache and serves it from there. And only if you have a cache miss in the local cache, it will go to the centralized cache and then get it from there. We ship with two providers for ASP.NET. One is for page output caching, and one is for ASP.NET Session State. They're built in. And so if you enable the local cache option, you get really low latency, and the objects don't even get serialized. They just get held in memory and accounted for in terms of memory pressure. The capacity is available in multiple sizes, 128 megs to 4 gigs. That's not the limit for your site. You can have more. You just choose multiple caches, and actually the API has a way for you to hook up multiple caches and just treat them as one. This is just the individual capacity for them. So this is where this all sits. Let's go and take a look at that. So here's the cache API sample. It's fairly easy. I have an object, a serializable object here. Let me just go get rid of this. So there's nothing, it's nothing special. It's just a product. It's got some properties. It's just a serializable object. And so that can be serialized. I'm actually using a string here, but I just wanted to show you that that's the kind of objects you can store, anything that's serializable. And so here, I can go and set up a cache. I'll do that at the bottom. So that's kind of all the options all folded apart. So you have a data cache factory. That's the thing that's creating it. You put in the factory configuration, and then you have a number of properties you can go and configure. The first one is the data cache security, where you put in the token that I have up there, the ugly string. Then you have a number of servers, and these are the server endpoints. So it's a collection. So if you have a number of caches that you have provisioned, you can go and reference all of them from the same client, and it will go and use them. You can use them all kind of together as a single cache. That's the request timeout towards the cache. That's the maximum number of concurrent connections. It maintains the connections to the server, obviously. It's all TCP based, so it's not doing HTTP requests back and forth. That is actually keeping the cache open. You have a number of connections you can keep open in a concurrent fashion, so that, and you tune this to up to the number of concurrent requests you get onto your cache, onto your site, obviously. So the more concurrent requests you get, the more connections you obviously need to the back end. And then you can set up the local cache here, and also set in how big your buffers are. So you have a lot of tuning, you have a lot of knobs you can go and control. And then using it, so I create, using this from the factory, using the factory I can get to my cache. The cache is now stored. And the way you use it is very simple. You go and add something with a key as an object, and that gets, if you have the local cache option enabled, goes into the local cache, goes into the central cache so someone else can see it. And that's the way, and then the caches all go and synchronize amongst each other. but it's a very simple model. It's at the end of the day, from a programming experience, it's just a key value store. Now, it has a number of additional capabilities. So this is the simplest model. It's just an add and a get and a remove. It also has a model where, and that's what we hear, so we have now a cache item that we add. Now we're getting it again. And now we go and update it, right, with a version. And now we try to, so we have now 2 copies, and now we go and want to update that again. So it's a version thing. You can't have concurrent access, you can't have concurrent writes, so that you have always, you have a versioned access, so nobody can go and override an older version, or can come with an older version of its knowledge of the cache and override a value. So that's optimistic concurrency control that's built in right there. There's also a notion of locking, so it's a fairly sophisticated API. It's the exact same API that we have in Velocity in the on-premise cache. So cache is fairly simple. Let's go and take a look at something else. That is right here. It's a web app. The web app is not very exciting. It's actually phenomenally ugly. Here we go. A meaningful drone sentence. Right? So what I just did is I updated ASP.NET session state, so that's not very exciting. Really? Let's go and take a look at how that was done. And the back, and it's not a modern app, it's just a web forms app. So it just goes and adds a new element to the session, and then goes and enumerates the session keys and just outputs them. So it's very simple. So this hangs in the session state. So the way this is done is all in here, where we have for the session state a distributed session provider that's coming from the distributed cache, from the cache assembly, so that's part of the SDK. You just hook that thing in, and then you can go and downstairs here, go and configure it. So now you're seeing parts of my secrets here. You can go and configure it with the host or the number of hosts that you want to go and target the number of caches, and that's all you need to do. And all of a sudden you have both page output caching. There's another provider that's up here that I haven't enabled, and also the ASP.NET session cache that you can very easily enable with those things. And so the cache is very, very simple to use. It has a really simple programming model. It gets more sophisticated for scenarios that need locking coordination, where you treat the cache more as a database than anything else. It's certainly easy to use for scenarios where you need speed in those kinds of apps. Be mindful that and I can't talk about pricing because we're going to announce pricing tomorrow. From a pricing perspective, you will have to think about whether you need the cache or whether it's okay to use the table store. This is clearly an option for accelerating the application that have high performance needs. So for many of you, the table store or a SQL session provider will just do fine. But if you have enormous pressure, then the cache is certainly an option. And for wherever you need to have a second level cache, or you need to go and aggregate data from multiple sources, where the acquisition of data is just expensive, and you put this all together, you need to have a place where you can put that, and cache is a really nice place to do that. That was the cache. Next thing, how do you achieve things like load decoupling between systems? So you have your web front end and you have your middle tier, and you get a lot of load, spiky traffic on the front end. How do you go and decouple that spiky traffic from your back end so you don't need to scale your back end to the most spiky traffic? It'd be nice to put a queue in the middle, and to put a queue in the middle that's reliable and that actually has the features that you need to do correlation, because you may also get some replies back onto the requesting thread. So you need to have a queue that does that. even nicer is if you have an event and you want to go and get that event to multiple places. How do you get that? It would be nice if you have some kind of pub-sub capability in the system. Also, another question is, I have an on-premise system that exists and that I have just introduced 2 years ago, and that still needs to amortize itself, so it still has to run for the next 5 years. So it's not going anywhere. But I want to build new applications that sit in the cloud. How do I connect those two? How does the cloud application talk back to my on-premise app without me opening up the firewall? It's all kinds of interesting challenges when you think about communication and integration in cloud scenarios. Because we've been teaching and preaching for the last 10 to 15 years that everybody should go and integrate their line of business applications. And now all of a sudden, we're talking about cloud, and you take one of those apps and pull it out and just move it up into the cloud. And what happens is like stepping into gum on the street. There's all kinds of tethers that are hanging off that app because there's all these communication links. And how do you make those work in a bidirectional fashion? It's kind of hard. So for that, we have the Windows Azure AppFabric Service Bus. That's the thing that I work on personally. And we have been commercially available since January 2010. We have a brand new community technology preview coming right around TechEd in May. We're putting the last finishing touches on it right now over in Redmond. And that's going to have a number of new capabilities. What it's for is for interconnecting services across networks. So I'm going to show you an example of that. And unfortunately, we don't have network in the room, but some of you may have 3G. So maybe we can go and do a audience participation thing. We'll see. So what it allows you to do is to take a service and make that service listen publicly on a public endpoint. So I can go and put up a service that you can go and consume from anywhere, no matter where I'm hosting that service from. So you have a service and you sit inside of the depths of a data center, and you need to make that service available to some app that maybe sits in the cloud. But you don't want to take that service and expose it on the edge of your data center directly, because that may be prohibitive in terms of cost or just prohibitive in terms of security. The big challenge is, how do you do that? So we have, just to give you examples of Microsoft, we're operating one of the largest intranets in the world, and we operate a large number of internal services that are just for operating Microsoft, making Microsoft work. And there's a mandate from senior leadership that says to Microsoft IT, hey, you must be running things in the public cloud. Right? Because it's also for ourselves, it's a cost factor to go and just leverage all that infrastructure that we have. So the Microsoft IT folks, they're looking at this and like, okay, so I have data in my data centers that are for on-premise, that are supporting Redmond directly. But how do I get now from this cloud application to the service which sits here in the data center? Because it's actually not feasible in many cases to go and expose those services to the outside world due to lack of IP addresses, right? Because not everybody has a public IP address. And just the sheer configuration complexity of exposing all those different endpoints. There's very many customers who have that exact problem, where it's nominally easy to go and expose a web service out, but then if you look at the details of it and the cost of it, it's actually hard. So how do you name and discover a service? Because if you have 3, 4 IP addresses, or you probably don't have one, but let's assume you just have a public IP address because that's what you get from your broadband provider, that names your gateway. It doesn't name the service. It doesn't name the host. It doesn't name the service endpoint. So we need to have an additional abstraction for that. It gives you connectivity through NATs and firewalls, and integrated authorization. And what we're introducing at TechEd is also a complete message-oriented middleware with queues and topics. And I'm going to show you the basics of it. I can't show you the API because that's the thing we're going to unveil at TechEd. So what's new in Service Bus, I'm going to show you the features that we have already shipping when I get to the demo. The new things that's coming is the queues. So we currently have a thing that's called the message buffer that's in there. And the message buffer is a little in-memory volatile queue-like structure that has a capacity of 2 megs and has a TTL of 10 minutes. You create a message buffer, you keep interacting with it. If you don't interact with it for 10 minutes, it goes away. And the messages can be 60K in size. The purpose of that message buffer is to be a little backing cloud store for an application that needs to synchronize data. So we have a customer, for instance, an airline in the UK, and what they do is they need to go and synchronize handheld devices amongst each other. So what they do is they throw messages into those little queues to just pull those down. And what we support here, what's different to the Windows Azure queue, we're also supporting that on the big queue, is long polling, which means you can go and park a request for 60 seconds, and after 60 seconds, if we don't have a message for you, we unblock and you come back. Or as soon as the message arrives, we give you that immediately. So you have very little network traffic with high responsiveness or good timeliness. So the new thing we're going to have is we're going to have an actual queue. So that actual queue is going to be backed by durable storage, built on top of SQL Azure. It's not going to have a TTL, which means you create it and it's there. So that's the same experience as with the other queue that we have, MSMQ. We own that too. The capacity is TBD. We're going to go into CTP around TechEd. The limits are going to be around 100 megs for the beginning. And then the message size is going to be capped to 256K. The capacity is something that's a TTP limit. We're currently trying to figure out what our actual limits is going to be. The aspiration is that we want to go into the gigabyte range. We just can't quite, we don't know how far we can go in the first step. Certainly, over time, we're going to get there. We're not clear yet on whether we can do that with the first commercial release. The other thing are topics. And topics is something that's familiar to everybody familiar with message-oriented middleware. For a lot of .NET developers, it's not so familiar. So the basic notion is it's a queue or a message log. And you send into this message log just as you would enqueue into a queue. And if you look at any individual subscription here, they look like a queue. So what this is a subscription that you can go and you create them in the system, and every subscription maintains a cursor onto that message log. So you read from the subscription onto that message log, and now all subscribers get a shot at getting that message. They can read that message, and there's filters, subscription rules, as we call them, with conditions, where you can go and filter those things out. So this is all serving for message routing. You can put an event into the topic, and then every subscriber has a shot at getting that message, inspecting that message with a rule, and then pulling that message out. So you get message distribution, effectively get an eventing system that's built into Service Bus, and it's all durable and reliable. So you get more on Service Bus in Christian Weier's session tomorrow at 1, I think it's in this room. So he's going to go into more details on that. But I want to go and show you very quickly, very briefly, because that's the other demo. Hang on. I want to show you very briefly, because I feel like I have to, a quick demo here. So I'm using my Sandbox account, so I'm going to be projecting a service from here through this network, which I have modified, onto clemens-sandbox.servicebus.windows.net/image. So opening up that service, we're going to go and go through it, but we're going to hit it in a moment. So what this does now, it goes and acquires a token. I sure hope that it does. Hello, good morning. There we go. So I have a browser here. The address is, so you can see this. clemens-sandbox.servicebus.windows.net/image. So if any of you with online would be quick enough, you could get this. Good. Let me go and get back there. So I'm going to hit it now for all the people who don't have that connectivity. Mark. And go to my browser window, which is up here. Hit it. And there are the Microsoft people. What did I just do? In case you haven't seen this yet, this is just a normal WCF service. So what we have here is an image service that implements an image contract. So the image contract is as simple as it gets. Right? It's a service contract, image contract. It's using the web programmer model, so it's using webget. Returns a stream. It stores the image. The image service here stores a bitmap that it reads from the file. So that file is this one, and no surprise, it contains that content. It then goes and wraps it in a memory stream, and then returns that memory stream, and sets the content type to image JPEG. So it's fairly straightforward. I host this using a web service host. So what that does is adds the web HTTP behavior. So that's all standard WCF. So far, no magic. The interesting thing happens here in the config, where for the service, I'm using the web HTTP relay binding. So there's a web HTTP binding that's part of WCF. I'm using here the web HTTP relay binding, which is the thing that sits in our assembly. So that sits in Microsoft.servicebus.dll. With that, I now change the game in terms of how I listen, because I no longer listen on HTTP sys, but I listen on the cloud. So we have a cloud listener infrastructure that you could hook into, and you can start listening for services. So that's what I'm doing here. So I'm setting up this binding, and now I'm also adding with a transport client endpoint behaviors with a shared secret credential. I'm saying this is me, this is my account here, and my secret. You've seen it. So now I have to change it. And that's effectively all I do, right? I'm modifying the relay binding here. I'm turning off authentication, which is enabled by default. So by default, there's an integration happening with the access control service. So I turned that off for that purpose here, so that we can see the image. And if you were hitting this the URL, you would actually get that image without authentication. But really what happens, and let me just use that picture, is I have the service running here. I walk up to one of the front-end nodes of Service Bus, and I register on the name. I register on my Clemens-sandbox namespace on the name image. So that's right by the root of the namespace. So the namespace is a root. All names that can exist in the world already exist. So I'm registering here on image. And any client that comes into some other node. We do some internal routing, and then we connect the two places, and that's the way how we do that connection. So it's an outbound connection out of here into Service Bus, and all the incoming connections come into Service Bus and get relayed through to you. Two ways to connect: TCP or HTTP. With HTTP, we can actually get out on port 80. We create a bundle of a long get and a long post. We bundle them together, put the SSL over them, take that bundle, put a set of pumps and pipes, and plumb that underneath the TCP stack to create the TCP emulation so that we can get out aggressively even in environments where we don't have open outbound TCP ports, but rather just HTTP. So that's Service Bus. Service Bus, you can go and host a service from anywhere. And that means you have services that are already using WCF and they sit in the data center and you want to go and have them connected to cloud applications. You change the binding or you add another endpoint, and that's all you need to do. And they're automatically secured in addition to that using the access control service and federated with the access control service. So you get you get queues, topics, all the things I'm going to talk about at TechEd, and you'll get the videos. And you get this connectivity capability. All very important. So we have cache, we have that. Access control. Vittorio had a talk in this room just before this one, so I'm not going to go into all that much detail on that. But access control is something that we just released. It's also part of Windows Azure AppFabric. And what that gives you is very easy integration into websites. And for those who haven't been to Vittorio's talk, I'm just going to go and do that once more. So I'm going to go and start from here and just go and start a new website. And actually, no, I'm going to go and make a new project. I'm going to create a new MVC app. It asks me what I want. I want to have an internet application. All right. So if I run this, something's going to happen, usually. Ah, there it is. It showed up but didn't tell me. So this is just a regular old app, and what that does is it's configured for forms authentication out of the box, assuming you have a data provider underneath it, which is usually SQL. So what we're going to do is we're going to make this app enable this for authorization, for authentication with access control, and that's fairly straightforward. So I'm going to go straight from here. Let me go and make one change, because that's usually what I forget. And we're going to go and bolt this to a particular port. So we're going to go to Properties, go to we're going to go and have that as a particular port. Let's go and have this at 62,000. So I'm going to go and save it. Fine. So that's what is going to show up the next time. And now we're going to go to the access control service. It also gives me a good excuse to go and show you the portal for a moment. So I'm going to go to, not the labs, I'm going to go to the actual production system. So I go to windowsazure.com. All of you will go, so if you go to windows.azure.com, you will get to the portal, and you will usually sign up with your Windows Live ID. It's also proposing that I do that here. I have a Windows Live ID that's actually this one. Also the magic of federation. Now it's going to tell me I have to log in at Microsoft. So you're already seeing access control happening here by ways of federation. Yes, this is my real password. And yes, I mistype it very often. So come back. So this is the Windows Azure the Windows Azure Platform Portal. Down here is Service Bus Access Control and Caching. Caching is going to show up very soon, as said. And I go to the Access Control Portal, the Access Control side here. And you'll see that I have a number of ACS instances here. They're all V1. The V1 instances, you can no longer provision ACS V1 instances, only we can. We do that because Service Bus, the current production version, that's what we're looking at, depends on ACS V1. So there's a linkage there between ACS V1 and Service Bus, the production version. The next big production refresh after the CTP that we're going to come up with is going to break this, is going to be able to federate with ACS V1 or ACS V2, but right now it's also all ACS V1 in production. So I have one namespace I call Team Heat. I'm building a demo right now, and that's why it's called Team Heat. And so that has that I can go and manage. So let's go and take a look at that. And unfortunately, the picture is a little blurry. I'm sorry about that. To federate, we just build an app that app sits at 62,000 on localhost. I'm going to create a new relying party app. I'm going to call this Demo 1. And I'm going to say that app sits at HTTP localhost 62,000. When the access control service gets a request, the place it should redirect back to is also the same place. And then we expect the token format to be SAML. We don't want to have it encrypted. Every token that's issued is valid for 10 minutes. And I have a number of identity providers already set up: Facebook, Google, Windows Live ID, and Yahoo. I could also set up Active Directory federation, for instance, with Microsoft. I have that already set up. There's guidance on how you can do that with your own Active Directory. You need to have ADFS. You don't have to have your Active Directory exposed to the public. You just need to have a way for applications to go and acquire a token from ADFS. So I go and save this now. Oops. How about demo 2? Okay, so I have that. Oh, I've been saving this. All right, so demo 2 it is. So now I have this definition. Now I have rules that apply to this. So we go now to the rule group here, and these rules, there are no rules here. They define how some input from Facebook and from Google and from Live ID and from ADFS, how that input, the name of the group in the case of ADFS, how those map into rights or permissions, claims on the other side. There's a default set that we can go and generate, so we're going to go do that for all the identity providers we have configured. So I'm doing this right now, saving all this. So I get the email address, I get the name, so I get all this data. And now I've got this configured. Now going to application integration. There's this wonderful federation metadata thing, and this document that's referenced has all the magic that I need for integration. So now I go into MVC, and I have the AppFabric SDK installed that has all the magic and all the tools. So I simply go, and also the WIF SDK. So I go add STS reference. The application URI is the one that we had, localhost 62,000. That's fine. I use an existing STS, and that's the one that we just configured. That's okay, that's okay, that's okay. Finish. Utility completed successfully. Now I'm going to recompile and run that app. This is what just happened. So we're on demo 2. It hit that page and immediately redirected us because we're not signed in. We need to be signed in. So it hit 62,000 and now automatically redirected to ACS. ACS now says, hey, pick your ID. This is a completely skinnable page. You can actually go and download. There's a JavaScript JSON-P call that you can make, how you can go and integrate this completely into your page. So the app that I'm currently working on, you can see a glimpse of that here, I think. Yeah, that's not doing. It's not configured correctly. But see, I am federating also with Microsoft in my app. I can go now to Google. That's okay. That's not a demo failure. That's just forgetting something. So I'm going to go stop this puppy because you're going to see that too, and so I'm going to make sure that that's not happening again. We go into here. So I just read the hint and implemented that hint. So now that page already remembered that I went to Google, so I go to Google. I'm signed into Google, so goes to Google, comes back to access control, and should then go and throw me back to my app. The network takes its sweet time. There it goes. See who I am? So that's I'm logged into my Google account, so that's picking up my Google account and picking up the name straight from there, and that's that. I could also go and log out. Let's go and just restart a new session. So that you can actually see that happening. So it's still it's again proposing that I do that. And let's go to Windows Live ID. See, now you actually get a page because I have my cookie saved for Google. So now I get to pick a Live ID. I can go and pick this one, and I get redirected back. Now notice that there is no name here. The reason why there's no name is that Windows Live ID in its terms and conditions doesn't allow, per its terms and conditions, doesn't yield the email address or name. So it gives you a key that identifies the user, but for federation with Windows Live ID, you actually get a unique identifier, but you need to go and ask yourself for the user's name and email address. We don't give that out in Windows Live ID. Facebook does that, Google does that, and we're leveraging all those services, but the Windows Live ID team has decided that they don't want to give out that data for privacy reasons, so that's why you don't get that here. But you can go and sign in with Live ID and have that as a security mechanism nevertheless. So that was, it's totally straightforward. What did I do to integrate? Loaded a new Windows MVC app, configured the access control service, and just configured this into ASP.NET very easily using WIF. And so it's not really hard. So the cache is very easy. Service bus is fairly easy because it's just config in many cases. And this here for integrating access control is also very easy. So that does that. So next step, and now we come to some the harder pieces. How do you deploy your apps? How do you add resources to scale your app? That's kind of the last mile, the last bits necessary to take a great piece of software and make it run as a service. I describe that as the iceberg. We have internal presentations. We've been shipping a service. We shipped a commercial service. And a commercial service is a big thing. And so far I've been talking to you about features, but making it really work and stand up and monitor it and deploy it and make sure that it stays up, that it's isolated, it's secure. I mean, there's a lot of work that's involved there. When we shipped Service Bus, so I'm on the Service Bus team, when we shipped Service Bus, we shipped practically in November 2009. That was the first release that we put out. Then we did a little bit of patches up to January 2010, but the functionality was locked and the system was effectively locked and loaded 2009 at PDC. We stopped building features in April 2009. Like there was feature freeze, and we actually cut stuff out because we couldn't get it to commercial readiness. The features were all working fine. We just couldn't plumb the monitoring, we couldn't plumb the billing, we couldn't plumb all the pieces that you need to go and plumb in addition to that. So some things had to go. So we spent more than half a year just with readiness, just with automation, just with billing, just with usage tracking, with all the things, with telemetry, all the things that you need to do to stand up a commercial service. So we've done that once. What we try to do is we try to take that knowledge and give that to you in packaged form, in the form of this platform, the hosting platform, that will also allow you to scale your applications. That takes the abstraction that we give you with Windows Azure one step further. We currently have a model where you no longer think about the individual machine in the sense that you have a notion of roles, and you have worker role and you have a web role. You also have a VM role, but mostly web and worker role. That's the Windows Azure programming model, and you go and program into those roles, and then you go and deploy, and you wish more instances of those roles. But fundamentally, it's still VMs. And you need to go and scale up and down VMs, and you have to think about VMs. What we try to do is we try to give you a way how to define components, the interdependencies between those components, and then we scale that for you. So application server infrastructure that we're building, Building on top of the pieces that we built for Windows Server AppFabric, which allows you to manage workflows and WCF services, building that out into a scalable hosting platform for components so that we can go and scale out your apps. So you don't have to worry about those all that much. We give you high availability and isolation. We give you your application. We give you all the pieces that are really hard to build as a platform. So that's our mission of our team for the next 12 to 18 months. And so let me go give you a little bit of a glimpse of that right here. And I'm just going to show you very briefly the notion here in the tool. So we have, we're going to have a tool, and there's, you're going to see that in a moment with the other view, how the composition where we can go and visualize the interdependencies and visualize and define the interdependencies between components. So you have here a web service. The web service is called by a web app. The web app itself has reference data that it talks to. There's a queue that it talks through to the benefits management service here, and then there's actually there are meters for measuring certain data that is accumulated on a per user basis. So it's a fairly simple diagram of the interdependencies here. What's behind this is really a model. And you've heard us talking about models, but now we're actually making this concrete, where you have all these different definitions that sit in here, and they have relationships. So they have imports, and they have exports. And again, we're still working on the exact experience of how that's going to look, but the notion is an export is whatever that service exposes to the outside world. So if I go and say add export, what you're going to see is a little dialogue that allows me to create a new endpoint on it and go and define that new endpoint. Imports is all the things that I know that exist, so I can go and add an import. And I have things that I have already referenced in my project, and now can go and hook those things up. What this yields in a fairly simple way is a thing we call currently an application model or a composition model. And that composition model is really important because it allows us to give you data back as we go and deploy the system. So if you need to know, so you effectively just talk to a service by name, but you have no notion of what the host is, you have no notion of what the port is, you don't have the notion of what any of these things are, because we automatically go and load balance them if we can. You never lose track of, if you have an instance and that instance holds state, we can actually go and pick up that instance and move it to a different machine because we're doing the name resolution for it. So all the components get logical names and we automatically assign it, we just move stuff around. But that gives us agility to go and host your application across that farm. And if you say, I need to have n number of components, more precisely, I need to be able to serve 2,000 requests per second, then we're just picking the right number of machines and the right number of resources to go and host that. We will also make sure that we distribute your application across what's called fault domains, which means if the app goes down, or if a part of the data center goes down, or a rack goes down, or a machine goes down, we have enough resources alive, if we scale it high up enough, that your app is not going to go die just because the machine underneath is dying. That all manifests also in, that's the right one, manifests in a management experience that's driven by this model. And this is the whole management view here, where you have a dashboard of all of your, so inside of your experience, you have this dashboard that's going to be hooked into this portal where you now see all of your deployed applications. You can see the state of all these deployed applications. This is currently deploying. This is started. We can go and take a look at those applications. We can see the same visualization, all the same interdependencies, and we can go and see details of how all those pieces are doing. That's all not very busy right now, as you can tell, because I likely clicked on the wrong thing. Let's go and see here what's going on there. What's that? There's an endpoint not found exception that has been logged. So it's integrated. The tracing is integrated. Monitoring is integrated. You have meters that you can go and show up. We collect the results. We integrate that with the topic infrastructure that we have. So it's a tightly integrated system. You're going to see more detail on all those pieces during the year. We're going to talk about that in more detail at TechEd. But this is where we're going. We're going to have a application infrastructure, application hosting infrastructure, an app server that sits in the cloud that takes a lot of the work away from you. And we're also eventually going to bring that down to on-premise. So the roadmap, when is all this stuff going to be available? In Q1, that's kind of already over. We released the access control and caching CTPs. We are already out with the access control service. Caching is imminent. We're going to have a CTP refresh also in a few weeks. The composite app or container, or however we're going to call it, that thing is also going to come out during PDC as a CTP. And the access control service is going to have a refresh. Caching is going to have a refresh. We're going to have an update for Service Bus. That brings the topics and the queues also this year, hopefully. So we keep pushing out new things. So AppFabric is the thing that will evolve over time. And we're planning to have something for the server sometime early next year, but we don't have an exact date for that just yet. So if you have questions following up to all of those things, I'll still be around for a few minutes. Then don't hesitate to ask me. Otherwise, I'm on Twitter at ClemensV, CLEMENSV. Follow me. That's actually a good way to ask questions, because if I answer questions there, then everybody gets to see those answers, and that's actually a good forum for that to happen. So otherwise, have a good rest of your show. Thank you.